All right, let's take a look at using fundamental identities. All right, on this first page here, if you look at the first three problems, we all have the same objective. We want to use the given trigonometric values to evaluate, if possible, should say all remaining trig functions. So we have secant of some angle u is equal to -3/2, given that the tangent of that same angle u is a positive number. So because we have secant's value, we need to find the other 5 trig functions. So for these first 3 problems, what we're going to use is a right triangle to help us do that. But that right triangle needs to be in an appropriate quadrant, the correct quadrant. So let's come over here and let's draw a coordinate plane. I don't know yet if I'm going to put my triangle, right triangle, in quadrant 1, 2, 3, or 4. That will be determined from the clues that are in the problem. Secant, you might remember, and have your formula sheets out and ready. Secant is r over x. So we have r, and we have x. I'm going to try and write it right here beside the numbers. Now r is the radius. It's the distance from the origin outward to the point. So we want to make sure that r value is always positive. So when you take a look at this fraction and it's negative, the 3 is not the negative. It's going to have to be that the 2 down here, or the x value, is the negative value. Now tangent is y over x, and all we know is that tangent's value is positive. Well, taking from over here that x is negative, then in order for us to get a positive tangent value, we have to also make y the negative as well. So what do we know about x being negative and y being negative as far as the coordinate plane? Well, when x and y are both negative, we're going to put our right triangle in quadrant 3. So from the origin, draw outward. You decide where you want to stop. Okay, bring the altitude up to the negative x-axis, drawing in your right triangle. Let's make sure that we label everything correctly according to the clues over here. R is 3. R is the hypotenuse of this right triangle. And x is 2. Actually, x is -2. Okay, now we're going to use Pythagorean theorem to help us find this distance right here. So we're going to square 3. We're going to square -2. We're going to subtract and square root. So Pythagorean theorem tells us that this distance is square root of 5. But remember, we are in quadrant 3, so we want to adjust to make that negative. So everything looks like it's labeled correctly. Okay, we have a negative x, a negative y, and of course your r value is always positive. Now from here, this is angle u right here. Okay, we can come up with the other 5 trig ratios. Okay, using u as our angle here, sine is going to be opposite over hypotenuse. Why don't we go over here and why don't we already go over here to cosecant, which is the reciprocal, and write down 3 over -square root of 5. Yeah, the negative could go up top, down bottom, doesn't matter at this point. All right, I already know that secant of u was given to be -3/2. So I don't even need the right triangle to help me evaluate the cosine. Cosine being the reciprocal of secant. All right, tangent. So we've got opposite over adjacent. So I could write down -square root of 5 and put it over -2. But when you simplify, just change that to positive. And then let's reciprocate over here. Remember, it's not our objective to rationalize. You guys know how to do that, so I'm not worried about these square roots in the denominator. All right, 2 more examples, same objective. Find remaining trig functions. Let's use a right triangle to help us. All right, let's get our coordinate plane ready here. I don't know what quadrant yet that I'm going to put my right triangle, but the clues are in here. All right, cotangent is x over y. So let's go ahead and make -5 a fraction. This is x, this is y. I don't know yet if x is negative or y is negative, but maybe this will help me figure it out. Sine is going to be y over r. This fraction is already positive, so at this point, the radius is positive 26, and the y value is positive also because of the value of this fraction. So if y is positive, that means that x up here is negative 5. So x negative and y is positive. Come back, let's figure out what quadrant we're in. X is negative and y is positive. We're going to draw a right triangle in quadrant 2. And this is phi. That's what they call that. And that's angle phi. All right. And using, I guess, the cotangent here, I'm going to say that adjacent x over opposite, it would label like this. Wow, that's really not to scale, but who cares? Pythagorean theorem, square the 1, square the negative 5, add together, square root to get the length of your positive radius. So that's going to be square root of 26. All right, and now we have all the information we need to come over here and find the remaining trig values. Oh, such a habit to do theta. All right, we already know what sine is. It was given in the problem. So let's go ahead and reciprocate. All right, cosine from phi is going to be adjacent over hypotenuse. And then let's reciprocate. Cosine, it didn't matter where the negative is. And then tangent, let's see, I know cotangent is negative 5, so tangent must be negative 1/5. All right, number 3. Tangent is y over x. Secant is r over x. So what must be negative? Not the 25, it must be the 24. So x must be negative, which forces this x over here to be negative. Well, if x is going to be negative here, and I need a positive tangent value, then the y up here also has to be positive. So negative x and negative y. That's quadrant 3. Let's just use this to help us. Let's see, secant is going to be r over x. That's going to be 25. And x will be negative 24. And then tangent is going to be opposite. This is x right here. Opposite over adjacent. So if this is 7, that's going to have to be negative. And then from here, go ahead and fill in all your trig values. Make sure that you're going to use all the appropriate signs as well. See if I can do this kind of quickly to move on to the other objectives. Secant is negative 25 over 24, so I'm going to go ahead and reciprocate. Let's see, what else do I know? Tangent is 7 over 24. So let's reciprocate here. The only things I have to find are sine and cosecant. So sine is opposite over hypotenuse, and then we'll reciprocate. And for the purpose of the answers right here, it doesn't matter where the negative goes. Even though we know 25 is positive, it doesn't matter. All right, so we used right triangles to help us find remaining trig functions given certain conditions. All right, we're going to change gears completely down here with these two and a few on the back. All right, the language of the directions are simplify the following trig expressions. Okay, these are not equations. There's no equal sign. These are just expressions that have multiple terms. So when it means simplify, oftentimes it means do algebraic things like factor, or even maybe distribute, or get a common denominator, and kind of clean this up to make it look more simple. So we're going to tap into some algebra. I strongly encourage you guys to get your formula sheets out and have those ready too, because I'm going to be talking about some of the formulas that are on your formula sheet. Okay, so to simplify, I'm going to take a look at these two terms. Terms are what you add or subtract. You might notice that sine of x is a common factor of both these terms. So my gut tells me that I'm going to factor out a sine of x, do a parenthesis, because you're making a multiplication problem. When you divide out or factor out a sine x here, I'm left with cosine squared x. And then don't forget your 1. The 1's necessary, so when you check your work by distributing, you do get that sine x. I wish I could say that we're finished, but we're not. I'm going to keep the sine of x. There's nothing more I can do with that, but I can rearrange in here. Remember, be careful and diligent. That square's on the trig function, not the x. If I wanted to, I could come back in here. I'm going to go to a bracket instead of that parenthesis. And what I'm going to do is I'm going to take and factor out a -1. So I'm going to take out a -1. That's going to leave me 1, and I have to adjust to a minus cosine squared x. I'll close my parentheses and I'll close my bracket. And the reason I did this, rearranged and factored out the negative right here, is because exactly right here, you might remember from your Pythagorean properties, we have those, and I think I had you write them at the bottom of your formula sheet, that we know this to be true, that sine squared x of cosine squared x equals 1. Now, if I wanted to, I could subtract the cosine squared x from both sides. I had you rearrange and get a couple different forms. So I'm going to subtract cosine squared x from both sides, and so I'm left with 1 minus cosine squared x. So what I'm going to do is I'm going to notice that this right here expression can be replaced with its equivalent sine squared. So I'm actually going to do two things. This -1 right here, I'm going to actually move it up front. So I'm going to have negative sine x. And then in here, what I have left, I'm going to replace that with sine squared x. I don't need the parentheses now. A lot of work. All right, now I want you to think of this right here as being something equivalent to this algebraic statement. If you were asked what's -x times x squared, the result would be when you multiply, you have a negative answer with an x to the third power when you add those exponents. Same thing here, it's just that we have trig functions as well. When you multiply all this together, you're going to get negative sine cubed x. Notice the cube is on the sine and the cube is not on the x. We're finished, finally. Simplifying is going to involve a lot of steps, some problems more than others. When do you know to stop? Well, you just kind of have to inspect the different parts of your problems as you go along. Like right here, I knew this was close to being 1 minus cosine squared x, but if I rearranged this expression, factored out the -1, I could make a substitution with sine squared x. It's just a lot of trial and error. If you think you're done, we'll finish. And if you don't see anything else to do, then we'll come back and talk about how you might finish if it is possible to finish. Okay, number 2. All right, what can I do algebraically when I look at these two terms? I hope you guys see there's a common factor of cosecant, so we'll take that up front. What's left in parentheses is going to be cosine squared x minus 1. Well, since we're just coming off of this problem right here, you might notice that this right here, when rearranged and the negative factored out, resulted in a negative sine squared x. If you see that, great. If you want to go through all the steps again, that's fine too. I'm going to change to a bracket to indicate multiplication because I want to factor the -1 out. You could put a -1 here. That's still going to be 1. And then parentheses bracket. And remember, that squared needs to go on the trig function, not on the x. So all of this is going to be replaced with sine squared, but the negative is going to go up front. All right, now for this problem right here, we're not quite done. You might remember that cosecant times sine of x is equal to 1. So look at your formula sheet too. There's some properties. There's a couple of ways to simplify this. You could change cosecant x to 1 over sine and divide out one of the signs. Or there's actually a property on your formula sheet. It's probably cosecant x times sine x equals 1. Or they might have it rearranged to where sine x is up front and cosecant x is behind. If I took 1 cosecant x and 1 sine x, that would equate to 1, and I'd still be left with negative sine x. Or another way is change cosecant x to 1 over sine x using reciprocal properties. Go ahead and put sine squared x over 1 since you made a fraction here. Now this is 2 sine x's multiplied together, so if I divide one of them out with that one, my final answer is going to be a negative sine x. So we took this problem and we simplified it. So this problem is exactly equal to negative sine x. We took this problem, we simplified it, and it's equal to negative sine cubed x. All right, we've got more to do. And then one more objective below that, okay? So let's look at 3 and 4. Do we approach 3 and 4 the same way? Well, we can try. When I evaluate both these terms, I don't see that sine is present in both these terms, so that tells me I can't factor anything out. So what do I do to simplify this? Well, I can't use factoring. So I'm going to use some of my trig properties. I'm going to work on this term since it's more complicated. I can't do anything here other than change it to 1 over cosecant t, but I don't think that's going to help me. So I can't factor, so what do? Let's work on this. I like to change, most times, trig functions to sines and cosines if I can. When I see cotangent of t, I think let's make cotangent of t a fraction with sines and cosines. I could change cotangent of t to 1 over tangent, but I mean, that's okay, but I don't know. You could go forward with that and probably end up with the same answer, but for me, it's just more understandable to change cotangent of t to cosine of t over sine t. Now times cosine of t, might as well make that a fraction, cosine of t here. All right, well, I've got a fraction here I'm going to multiply. I might as well make sine t a fraction. Multiplying two fractions together, you multiply the tops. That's cosine squared t, squares on the cosine, not the t, over sine t. Oh, I am not making this more simple, but there must be something else for me to do. Well, let's get a common denominator. This fraction has sine t in the denominator, so let's make this fraction have sine t in the denominator. So let's multiply by that form of 1, sine t over sine t. So I'm going to end up with multiplying and getting sine squared t over sine t plus this fraction. Let's put these two fractions together over 1 sine t Look at your formula sheet. What can I replace sine squared t plus cosine t squared with? That's actually equal to 1. Keep the same denominator. Instead of having a fraction answered, let's rewrite this using reciprocal properties as cosine of t. All right, let's look at 4. Pause, go back and rewatch number 3 if you want. I know that goes kind of quick. You might have missed something. If you watch it a second time, rewind, you know, it might come to you the second time. Let's look at 4. What should I do to simplify this? Well, I don't see a common factor. Let's try the same approach we did on number 3. I might change cosecant to 1 over sine. That might help me. If it doesn't, if I see later in the problem that changing cosecant of x to 1 over sine x by using the reciprocal property doesn't help me, I'll change it back to cosecant of x. Cosine's fine, but I'm going to change cotangent to cosine x over sine x. Remember, this could be made into a fraction as 1. So this is going to end up being similar to this previous problem. Multiply these two numerators and get cosine squared x. Remember, the square is on cosine, not on x. Oh, we got lucky here. We don't have to get a common denominator because we already have the same denominator. So let's collect the two numerators, putting them over sine x. What do you remember about 1 minus cosine squared x? Because are we done? No. 1 minus cosine squared x is equal to sine squared x. And we still have the sine x here. Okay, remember on top, this is sine x times sine x. That's why we have sine squared x. So I can divide one sine x out with one of these. My final answer is sine x. All right, if you feel like you need to go back and watch those 4 examples, you might want to for the process of simplifying and some of the things that we did. All right, these last problems down here have us factoring trigonometric expressions. So let's see what we remember about factoring, but how factoring might look the same as factoring trigonometric expressions might look the same as what we've done in the past with factoring algebraic expressions. Let's see. I'm trying to think about maybe skipping around here a little bit. Let's start with number 4. Factoring. Well, this is one term. It's a product of secant squared x and tangent squared x, and this is another term. I see that I have a secant squared x in both terms, so let's factor that out. Check your work by distributing back in, making sure you get back up here. So am I done? Well, yeah, I did factor, but should I do some simplifying? Probably. I don't see that I can simplify this, but what about one of the Pythagorean properties? 1 plus tangent squared is equal to secant squared. So I'm going to replace this factor with secant squared x. That's on my formula sheet. Now I can multiply these two trig functions together because they're both secants and combine the exponents by adding them. Think of this as being x squared times x squared. That answer being x to the 4th, but just now with the secant in it. But again, the 4 is not on the x, so my problem, the 4 is on the secant. So did we factor? Yes, we did, but we also had to further simplify. All right, let's take a look at number 3. All right, some students, I'll just kind of let you know, are kind of tempted to go ahead and divide out this cosecant with one of those. Unfortunately, we can't do that because we're not multiplying. You know, everything has to be multiplied before I can divide out. I have to have factors. So that's not going to be possible. I'm going to show you something that you've done in algebra before that this is similar to. I want you to think about this algebraic fraction. Think about x squared minus 1 over x minus 1. You would not have divided an x out here and an x out here. That's wrong. What you should have done is taken the numerator, seen that it was a difference of 2 squares, factoring it into sum and difference of like terms. X squared minus 1 comes from this product. Once you get factors on top, you can think of this denominator as a group, and you could divide out the common factor. That's the same thing we're going to do over here. We just have trig functions. The denominator doesn't factor because I don't have a square here, but the numerator does factor. If you're not sure about that, once you pause and just multiply these together by foiling, make sure you get back to cosecant squared x minus 1. I can think of the denominator as a group, a factor, and I can divide it out with the numerator's factor. That's the like factor. My final answer is cosecant x plus 1. And there's nothing more to do there. All right, let's see. Let's practice some more factoring. Let's go to number 5. Okay, number 5 has 3 terms. We have a constant, a square, and then we have a double of square. We have a 4th power. Well, I'm going to come over here and kind of equate this to something algebraic you've done. Think of this problem as being 1 minus 2x squared plus x to the 4th. If you were asked to factor this in Algebra 2, or college algebra, we could break that apart into 2 parentheses that multiply and give us this. We need a 1 up front in both of these, so when we FOIL, we get back to 1. The only way to get x to the 4th is to have an x squared here at the back end and an x squared here. So x squared times x squared gives us x to the 4th. How do we get minus 2x squared? Well, both of these binomials should have a subtraction in it, so that when you check to get x to the 4th being positive, negative times negative is positive. This is the same thing here. It's just that we have the trig function of sine in it. So I'm looking at this going, oh, how do I factor it? Well, let me see if I can just immediately break it apart. I need a 1 here and a 1 here. What do you think goes into the 2 last terms? If you said sine squared x, you're right. Think about that for a minute. Sine squared times sine squared gives us sine to the 4th, but we need negative 2 sine squared x's, so we're going to make both these negative. Check by foiling to make certain that you get back to this problem. Okay? We could, I guess, factor some more here. Let's look at each individual binomial. Like, for example, just focus on this. That's actually a difference of 2 squares. This parenthesis can break down into 2 parentheses. Well, I can do the same thing here as well. 1 minus sine squared x is 1 here, 1 here. But to get sine squared x, I need a sine x here and a sine x here. But notice I don't have a middle term, so this is going to be 1 plus and 1 minus. Foil these 2 together, make sure you get back up here. Once checked, same thing here. You're finished. You could clean this up a little bit. Notice you're multiplying 4 factors together. These 2 are the same. So I can kind of collapse it and say it's 2 of those times 2 of these factors. Let's take a look at 6. 4th power, 4th power. I can't use the Pythagorean properties because I need 2's as my exponents, but I do see this as a difference of 2 squares. If I put secant squared here and secant squared here, I would get secant to the 4th. Likewise, tangent squared here and tangent squared here. Now, what kind of signs need to be in here so you don't get a middle term? Well, one has to be plus and one has to be minus. Double check, because when you multiply these last 2, you should get that negative. All right, are we finished? How do we know? We just take a look at what we have. Okay, what I would say is look at your Pythagorean properties, because now we have exponents of 2, and that kind of throws me into those properties. This is actually equal to 1. This is 1 times this other parenthesis. Are we done? Probably. I could probably substitute in something for secant squared x, like 1 plus tangent squared x, and clean it up. But I would say, you know what? We're finished. Do we have to show the 1? No. All right, let's go back to problems 1 and 2. Okay, let's look at problem 1. How do we factor this trig expression when I don't even have the same trig function? Well, I can't factor this unless I have the same trig function. So I'm going to change cosecant squared x to something that contains cotangent. Go to your Pythagorean properties. One of your Pythagorean properties shows us that 1 plus cotangent squared x is equal to cosecant squared x. So how about if we substitute in for this term 1 plus cotangent squared x? Bring down the rest of the problem. Clean it up. I'm going to put the second power first. Positive 1 minus 3 is minus 2. Now, can I factor this? think so. I need a cotangent up front and a cotangent up front here. Factors of 2 are going to be 2 and 1. One of these is going to have to be a negative and one's going to have to be a positive. Well, because I need a negative cotangent in here, the bigger number should have the negative in front of it. Check your work by foiling. You should see that it results in this previous line. All right, looking at number 2. We need tangent from secant squared. I wouldn't want to change tangent back to secant squared. It'd be complicated. But remember, secant squared x, it's involved in this Pythagorean property. So like problem 1, oops, I need an x. I'm going to replace him for secant squared 1 plus tangent squared, clean it up, and then factor. Putting those two together. Now we can factor. These two will give us tangent squared. Factors of 2 are 2 and 1. I need a positive 3. So, and this is also positive here, so they both have to be positive. And there's nothing more you can do with each of those individual binomials. Okay, moving kind of quick, let's look at 7. 7's different than the previous problems because notice that you have 4 terms. You've got 1, 2, 3, 4. Okay, this is kind of a built-in clue, but when you have 4 terms, you might want to think about factor by grouping. Let's put these 2 terms together and these 2 terms together in parentheses. I've got this minus here, and I'm going to put these last 2 terms in parentheses. But I don't want to put a plus here. I want to put a minus so that when I go back and distribute that negative in, I get back to that plus. Factor by grouping next says, okay, we've grouped the first 2, the last 2 terms. Now let's look for a common factor in each of those. So I see that secant squared x can be factored out front, leaving me secant x. When I multiply, I get secant cubed minus 1 minus. Can't factor anything out here other than just a 1. So I'll go ahead and make it visible, put it up front. To continue factor by grouping, now I look at these 2 terms. Notice your common parenthesis of secant x minus 1. Let's factor that parenthesis out of each of these 2 terms. So when I take out secant x minus 1, I'm left with secant squared x. When I take out secant x minus 1, I'm left with minus 1. Right, it looks like we're almost finished. However, this is a difference of 2 squares. So keep the first parenthesis. This difference of 2 squares needs 2 parentheses because I can put secant x up front here, secant x up front here, and I need a 1 and a 1, and one's plus and one's minus. This answer's fine, but when you notice you have 2 of the same factors, we usually just put them together with an exponent on them. That's it.